Hello and welcome to CDW's Tech Talks. This is the podcast where we dig into technology, trends, and try to provide practical insights that shape how organizations can use technology to solve real business problems. I'm your host for today's episode, KJ Burke, Field CTO for Hybrid Infrastructure at CDW Canada. Today's episode, we're going to do a bit of a recap on GTC 2026 in California, talk about some of the key things coming out of that, and then I'm going to give some of my thoughts on the things that really resonated with me. So looking at GTC 2026, first of all, what is it? GTC is really one of NVIDIA's sort of flagship conferences where they bring their partners together. They do keynotes. They cover everything from sort of the consumer side with the graphics cards, but most of it is centered around AI and what's going on in the AI world. And that's kind of expanded into, I think, robotics and as simulation and things that become more important. Also, a little bit of information around like quantum computing and how there's going to be this combination of CPUs, GPUs, and then quantum qubits really being used to help organizations do some of those very very specialized compute that quantum can provide. So it's really become sort of this all encompassing landing space for all of these different ideas to come out. Really good sessions, really good innovation sessions that I had an opportunity to sit through, and then hands on. Actually seeing some of the robotics, seeing some of the simulations in person. It's very very different than seeing it in a video and seeing it online. So GTC is one of these big congregation points. Kind of reminds me a bit of some of the conferences like Comdex back in the day, or these very very large, like CES is also, I think, a really interesting place for some innovation and having those conversations. So GTC 2026, I think, really came down to a major strategic pivot. And a lot of that pivot was away from focusing so much on, training models and production scale inference, and really started to talk more about physical AI and leveraging AI to help the production of robotics and things like that. So, just sort of browsing and sort of seeing what the topics that were trending after GTC were. First of all, the Vera Rubin platform and its successor to Blackwell and its architecture. So, what one of the things Jensen talked about on the main stage was the inferencing era and the need for inferencing for organizations has really begun. And I think what we're seeing is this move away from chatbots and SaaS services to a lot of organizations looking, well, how do we take our data? How do we use it in a fenced way? How do we inference at scale? And whether that's going to be done in a hyperscaler, whether that's going to be done at the edge, or whether that's going to be done in the data center, the need to have that performance to continue to provide more tokens for the same number of kilowatts, continue to grow the capacity and our ability to, store and provide that data and that storage to these GPU inferencing infrastructures is becoming more important. So increasing the performance, optimizing the cost per token, those are some of the things that are really focused on there. A second thing was around agentic AI and the OpenClaw approach to agentic interactions with your software and your applications and things like that. And so one of the big differences, though, and I think as an enterprise focused technologist, I think it's key that we get some guardrails around these tools, because what happens is if they're not controlled and they're not we don't really have a better system of governing the data they're working with, the systems they're working with, the changes that they're making for us, kind of just becomes chaos. And in an organization or an enterprise, that chaos could be significantly damaging to your business. I think NVIDIA's approach around OpenClaw and that whole sort of evolution of agentic AI was, well, can we start to create something, in their case called NemoClaw, which would focus putting guardrails and maybe have more of a zero trust approach to using that. So I think that's a big thing, and I think organizations should be looking at how how does OpenClaw and tools like OpenClaw potentially change the way we do our business if it has guardrails and security wrapped around it. So I think that we're all still struggling, with how we get to that point. But I do think there's going to be a big push once we have an approach to securing and making those available. Um, Physical AI and the robo taxi push, that was another one that came out of it. I think to me, I'll talk about this more in my thoughts, but really, it was this focus on robotics, is this focus on the physical interaction of AI with the real world, and I think a couple of things driving that are simulation and the ability to do simulation at scale. Repeat a specific task millions and millions of times to help robots understand, how do they physically move within the world, and there were some limitations there I'll kind of talk about in a second. Um, and having some of the foundation models for those simulations, whether that was, a world model, whether that was robotic models like Groot, that was shown there, and then also looking at some of these tools like self-driving and how there's now platforms for organizations, like BYD, Hyundai, Nissan, to build their autonomous driving or their self-driving or their driving support on a platform, as opposed to sort of a closed system or a proprietary system that maybe their competitors own. So I think all of that was really, interesting. AI factories were a big topic. I think sometimes the conversation around AI factories is happening at a size and scale that maybe isn't as relevant for, mid-market or startups or even enterprises to some, to some extent. The need for inferencing, absolutely. I think we should all be looking at how can we start to optimize access to data? How can we start to optimize our pipelines of business processes? There's a lot of value in that. But when you start to talk about like gigascale of AI and token generation, I think it's only really targeting a few organizations in the world. And I think there's a lot of advancements that are being made there that will have a trickle down effect on enterprise. But when we start talking about, gigafactories and things like that, it's just not as relevant for a lot of the clients and the customers that I talk to. Overall, though, we're seeing again this driving down of cost per token. We're seeing an optimization of models to use less tokens. So I think it's kind of compressing. It's if the models are getting more efficient with their token use and providing more value per token, and the tokens are becoming more accessible because the cost of the tokens is going down. We kind of have this squishing effect of, now I can get more out of it. I can invest less capital, and I can start to see those payoffs sooner. So I think that's really neat. Another one that everybody was excited about was space computing and getting frontier models out to into space. I mean, there's a kid inside of me, the same kid that watched, NASA launch the space shuttle multiple times. There's part of me that gets excited about that too. I think there's a lot of, interesting stuff, especially when you talk about like healthcare research, the effects of space on the body. How do we start to move into space, and is that colonization? Is that mining? Is like, what can we do there? I think there's a lot of really interesting things, and one of the keys there is we have to be able to do experimentation and do simulation and do all of that in the environment of space so that we can be more effective. So I really view space as sort of the ultimate edge computing. How do we get resources to the edge? How do we do it in an optimized way that we can continue to grow and innovate and explore? So I think that's really really exciting. But the feasibility of having, gigafactories in space, I think is I think there's some significant challenges. One of the customers that we talk to in the aerospace industry, when they're launching satellites into space, obviously heat generation is not a problem, but weight, and the density of the materials. Space is also a little more active, especially the more satellites, the more debris that ends up orbiting the Earth. All of that becomes, potentially problematic for space institutions, and so I think that's pretty, definitely something we have to keep in mind. Now that's kind of those are some of the big topics that kind of came out of GTC. I want to talk specifically about some of the things that I experienced, some of the things that really resonated with me, and I try to bring more of a practical approach to the way that we kind of go about this. And so let me start with robots. Um, Robots are very interesting. I've got a video. I don't know if I could post it or not. I don't think it's not safe for work or anything. But basically, there was a Dell robot that was trained to be an insult comic. So I would say kind of Don Rickles light, or um, trying to think of a more contemporary example, but really just kind of there to to take cuts at what you were wearing and what you're doing, and just kind of make fun of the whole process of being at a conference. So I thought that was really interesting. And with that, talking with the operator of the robot, hardest thing was to get it to be funny, but in a corporate environment where it wasn't too insulting. And so that was kind of interesting. And the way that was done is really through simulation and human in the loop. And so the reality behind the scenes to me was even more interesting than the unit itself. Um, Another session that I attended was talking about some of the challenges of robots. So I think there's this fear, uncertainty, and doubt around robots that we all have, and I think a lot of it's legitimate when we look at how's it going to impact our day to day lives and how is it going to scale and that. Who's going to control the operating model of the robots? I think those are things that we need to have conversations about. But also understanding what is easy for a robot to perform, what's hard for a robot to perform. And, knowing that robots can do complex dances and they can do martial arts moves and they can do flips and they can run. That's really in the context of simulation with structured surfaces. And so when you think about the ground, for the most part, has some variation, but it's a structured hard surface. A challenge for robots in general right now is, say, plugging in an Ethernet cable, where it is an object that deforms. It's a cable. It doesn't have the rigidity of the ground. And so when you start to realize and you start to dig into what's actually achievable by robots, I think some of that fear, uncertainty, and doubt goes away. But again, we're seeing a lot of advancements in simulation. We're seeing more simulation. We're seeing these open platforms for robotic simulation. So I do think we're going to see some significant advancements there. But it isn't at the point where all of these tasks are very easy for robots to perform, which kind of directly impacts the second one. So simulation to me is one of the big takeaways. Empowering a physical world, the interactivity for AI is very interesting and exciting and novel. And I think one of the things that really showed me this in action was one of the medical healthcare panels that I went to. And in that panel, there was a surgeon, a doctor, that was talking about the use of robotic procedures to basically operate, internally on doing things like laparoscopic surgeries and heart surgeries and things like that. And so simulation in improving the quality of those systems, the improving the way that people can use those systems. And then also the connectivity of people using those systems. So being able to have an expert that is very distant also contributing to the surgeries. And so there was a lot of really, really interesting and I think innovative ways that simulation can be used for training, that simulation can be used for building more precise instrumentation and movements of these different tools in the time of a surgery. And then there's also things like digital twin. So digital twin being able to say not just for a factory, but take the digital twin of your body and have the surgery team put together the game plan on how to get to the area of the operation. Also being able to visually map in real time the organ that they're doing the surgery on, and then also being able to put some of the information onto that and overlay that in real time so that the surgeries could be more successful. And so really focusing on the results for the patient, focusing on technologies that can make that more effective, that can really improve that patient experience and speed up their recovery was really, really exciting. So digital twin was kind of the third one, and being able to build things digitally and then use that to improve the outcomes. And I think we're really just getting started there. I think the idea of creating digital twins and leveraging that information to create better client outcomes is going to be huge as we go forward. Um, Fourth one for me was really around OpenClaw. There was a booth where we were able to sit down and kind of interact with OpenClaw, and it's really powerful. It hasn't been in the news as much lately, but I think when you start to think about having an agent, being able to give that agent the latitude to do the work that you need it to do is really exciting. But on top of that, we need guardrails. We need to have guardrails for control of the information that's being sent. Is it from a trusted source, so that the actions that are being acted on are starting at the right place? Needs to be guardrails and controls around what it has access to, not just be open for everything. And then we need guardrails on the outcomes, and we need there needs to be the ability to have human in the loop for some actions that we're not comfortable with that agent performing. So I think there's guardrails, there's observability. It's kind of all of the things we've talked about, but the power is definitely there. The ability to have the execution of the tasks you need is really, really exciting. Um, and then the fifth one is more of a business topic, but that's really the need for AI and NVIDIA, but also other organizations like AMD, like Intel, storage providers, all of these infrastructure organizations. There's a need to pivot away from hyperscalers into growth in the enterprise. And so at the same time that I think enterprises are realizing there's a lot of value in moving past chatbots and SaaS services, all of these organizations need to pivot away from having only a few, customers in the hyperscaler space. They need to pivot to having all of the customers that they could possibly get in the enterprise and the small business and the medium-sized business and the startup space. And so, we need to help architect and design and deploy via platforms. We need to help organizations quickly adopt and see value from these AI projects. So I think those are sort of the top five I had. Robots are ready. Sort of simulation is really powerful, and I think we can find new novel ways to simulate things. Digital twins are not just for manufacturing. I think we're seeing some novel use cases in the healthcare industry that's really going to drive some great patient outcomes, which is really exciting. I think OpenClaw it has more impact to be had, but I think we need to figure out how do we wrap guardrails and checks and balances into the system, and then also how do we pivot away from just being organizations that have SaaS services into really innovating the enterprise. And that's important for all of our key partners. So, happy to engage around a lot of those things to help, you develop your strategies, talk to your account manager about that. And then, I just want to say, the conference was really well done. It was interesting when you think about the logistics of some of these conferences. At one point there was a fairly long line because there was a bag check, and I was there for maybe 10 minutes. And in that 10 minutes, they had already built a second line to do more bag checks. And so people just wheeled in the X-ray scanning machines. They set up a whole new metal detector, and they just kind of like got people through it. So it was kind of interesting to see in real time some of the ways that the conference was trying to optimize itself. And so I kind of wonder, like, what type of analytics were they looking at? Q depth? Was there some sort of an AI process that was taking the data from people standing in line and then feeding that real time to some sort of a dispatch crew? So there's some really interesting stuff there. And definitely encourage you guys to attend if you can. If you can't attend, I believe all or almost all of the presentations are available. So go search up GTC 2026. There's tons of good information there, and even though attending it, I think you get to ask more questions. You get to get hands on. There's a big area where you're looking at. One of the things I looked at was an AI robot. It basically helped with weeding in a farm space, and so you've got a field, and being able to identify weeds and remove weeds, and do that 24 hours a day, 7 days a week, for the whole time that your crops are growing. It's kind of an interesting sort of novel thing. So I think if you have the opportunity, there's a lot to learn there. But I think there's also a lot you can learn just kind of going back in and looking at some of the sessions that are of interest to you. Um, so big thanks to the team, and putting together some of these other insights and some of the different things coming out of NVIDIA's GTC that are really important. And thanks for listening. I appreciate it. For tech tip of the week, I think my tech tip from an NVIDIA perspective is go to the GTC website, take a look at some of those presentations. Definitely, some of the healthcare stuff was really really interesting. Look at some of the quantum stuff and how quantum is being sort of integrated into the overall compute stack. Um, and then, go take a look at build.nvidia.com. There's a bunch of blueprints out there. They've got their NIM systems. Look for OpenClaw to show up there if it hasn't already. Uh, Note to self, I gotta take a look at that. But yeah, take a look at that. Dig in. Be inquisitive. And if you have any questions for me, just reply to this. If it's in Spotify or if it's in YouTube, feel free to let us know. Try to create more interactivity, but it's also, sometimes it's not comfortable replying out on the web, but no problems there. Thank you for your time. This has been the CDW Tech Talks podcast, and we'll catch you next time.